Okay, so already copied this in your Do Now, but if you still need to jot something down, please let me know. We're just talking about the alternating series still, but we did all of the tests. We're done. We did the 9th test, the 8th test being the alternate series test, and the 9th test is whether or not it's an absolute or conditional convergence. Okay, so that means we just are looking at an interesting aspect to our alternating series. So there are hardly any series that we're finding the sum for. And we're getting down to the alternating series. We're still not going to find the sum, but we can use this. It's an estimation theorem. Okay. For the alternating series to see how close to the true answer that you're going to get. So I know that you wrote this down, so the word should make sense here. Basically what this is saying is that there is an error. Okay, that's why it's an estimation theorem, so you're a little bit off. And that error for the sum, so what it would be from, let's say, a few terms, like an n term or a finite series, okay, is going to be less than or equal to the n plus 1th term, okay, which is basically like if you're adding up, let's say, the first 2 or 3 terms, and you know the 4th term, okay, you're able to get this error, and this is for an alternating series. It's an alternating series error bound. So make sure that you have this down. This is something I'd write on the board. Make sure that you get it and you kind of understand it. Now, there are a lot of AP Calc problems that ask about, okay, show whether there's an error less than this amount. So they may not want to know exactly what the sum is. So I'm going to show you a question that is very, very similar to the AP exam, and I'll do another one just to explain how we can kind of write the sum, okay, between two values, something like this, okay? And that would be pretty cool too. Okay, so it goes that let f of x be, and if you look at it, it is an infinite series. It is an alternating one. You see how like the signs are changing. Actually, particularly that's the nth term right here. This is the expression. You see like you have negative and positive. It started with a positive, went to negative, went to positive, etc. So it is an alternating series. Okay, and I scribbled all over the questions, so hopefully, let me erase all this. You're writing it down, and you get to show that 1 minus 1 over 2 factorial plus 1 over 4 factorial approximates f of 1 with an error less than 1 over 500. Now, so far you haven't seen sequences or series that has a variable of x inside. Usually it's just to the nth power, like you see here. This is a sub n. Okay. In future lessons, you're going to get to see more of this. However, it doesn't mean that we cannot do this problem. We certainly can. So, the first thing that we want to do, okay, is to obviously see that it is alternating. Okay, so it is an alternating series. And we can say that by seeing we have negative 1 to the nth power. All right. What we next want to do is use that like summation. So we're saying that we're approximating f of 1. Okay, so that would be our sum. and it should be found with just this amount. So you're adding up just the first 3 terms. So we have to figure out what that is in order to continue working this out. Okay, but that means to like simplify this expression. So we have f of 1 minus, now 2 factorial is 2, so that's going to give us 1/2 plus 1 over 4 factorial. 4 factorial is 4 times 3 times 2 times 1, or 1 times 2 times 3 times 4. So you should be getting 1 over 24 here. Okay, so that's going to give us that f of 1 minus 1 over, or I should say 1, I'm sorry. Okay, it should be 13 over 24. I think in my mind I was adding 1 with 12. Okay, as you make a common denominator, that second number would be 12. And this has to be less than or equal to the next term. So we have to figure out what the next term would be. So that would be like our next step after this one, like setting up the left side. So we have to set up the right side. So if we have 1 over 1 factorial, okay, that's what it would be there, minus 1 over 2 factorial plus 1 over 4 factorial, okay. Now, this would make sense, except if you look at the denominators, it's 2 factorial, 4 factorial, so maybe it's not 1 factorial. I know it's 1. Maybe it's something else. 0 factorial is also 1. There's a little proof that you can do in order to actually see that, yeah, that's true. So you could go back and prep a little bit on factorials. That is true, it's 1. Now this makes more sense that the next denominator would be 6 factorial, and it is. Now, it also makes sense that we're sticking with 1 as our numerator, except there may be a sign other than a positive, because this was positive, and then this was negative, and then this was positive, so this should be negative. So make sure you have a negative sign there. Well, since it's in the absolute value, our fourth step is kind of putting this all together. Okay? So this is going to give us, actually, I just said it's in the absolute value, just a positive 1 over 6 factorial. Okay, so we know that 4 factorial is going to give us 24. Okay, if we multiply by 5 and we multiply by 6, we get 6 factorial. Well, 5 times 6 is 30. And if I multiply 30 with 24, I'm going to get 720. So that's great. Okay, so here we go. Let's discuss. So we have f of 1, okay, and yeah, we have the minus 13 over 24. This answer has to be less than or equal to 1 over 720. So, okay, we're saying here that it's going to have an error that's less than 1 over 500. I don't know why I keep saying that when I see the 1. I'm sorry. So let's think about the comparison between these two numbers. Okay, so this may even equal 1 over 720. Okay, but this is supposed to be less than it. Now, 1 over 720 is definitely less than 1 over 500 because the denominator is bigger, making it a smaller fraction. Okay, so the error is less than we expected, and that's all that we need to kind of do there. Okay, so let me erase this and just show you something. So there weren't many terms that we needed to actually use to talk about like the error that we have with an alternating series. So let's take a look at another alternating series and talk about, well, where is our sum exactly? So that way we can be a little bit more hands-on with our sum. So I found this alternating series. So you could take any one that you want. And this is just the notes that I have. Maybe this is a practice problem that I gave you in class. So we did find that our series converges by our alternate series test. Okay, so then we would proceed to maybe have a question where it's talking about maybe the first three, or let's even say like the first two terms. Okay, and let's see what its sum said. So our first two terms for this sequence, okay, so let me erase this, and we're just focusing on error of an alternating series or an infinite alternating series like this one. So our first two terms would be this. I'm just trying to write it all out so it's kind of clear to you what we're using here. And we have -1 over 5. And, okay, it looks like we have 8 over 25. All right. So what's happening is that our first two terms, okay, that we have is going to be this. Now, it's our third term that we're going to compare our error to, okay? So our third term, if we're to use this formula again, but this time, let me find a different color, with the third term, we would get a negative answer, okay? And we'll have 27 over 125. So if you want, this is what would be in our absolute value. And you can just change this over into a positive answer. So what does this mean for our sum? So let's rewrite our absolute value, okay, of our error here. I just need space. Let me erase this here. There we go. This is going to make a lot more sense. So what does this mean? Our sum is going to be between certain values, okay? So our 27 over 125, if we subtract that fraction or add that fraction to the sum that we had over here, which I didn't actually find just yet, then we would know what our sum of our series is between. Okay, so let's actually do that. So if we make a common denominator, we're going to get 3 over 25. So this seems like we're going to have -2 over 125 as a possible sum. Okay, or it's between this and, wait, I kind of jumped the gun here. made the common denominator correctly. So if you multiply by 5 in both the numerator and denominator, we get negative 12, okay, as our numerator. So our sum is between negative 12 over 125 and 125 as our denominator here, and our numerator would then be 42. Okay, so if you are able to reduce these, you can. I don't see that 3 goes into either one of these, so, or 9. It seems that our sum are between these two values. And if you want, you can write them as decimal form. You can leave them as fraction. Typically, like if this part comes up on your AP exam, it's probably not with the graphing calculator, so I would just leave it in fraction form. Make sure that you do write your fractions correctly. Don't just start writing the common denominator, and be careful. So hopefully you can see how to use the error bounds, and let me know if you have any questions. Good luck.